So, how do Polar Bear Design products fit into modern climate control systems? Well, despite solving the same problem, that of keeping a space at a given temperature, modern climate control systems come in a wide variety of shapes and sizes. This video will explore the ways that Polar Bear Design's thermostats, Zentium 2 Inertium, and controllers, UMC2 RS1 and UMC2E, fit into common scenarios. And by the end, you should have enough information to begin planning their role in your own projects. There are three key project types that we'll look at here. First, standalone control of a room's AC unit. Second, standalone control of multiple rooms with heating and AC. And finally, integration into a building management system, a BMS. It's important to note that your project might have some aspects that mean it falls somewhere between types. For example, you might have an otherwise self-sufficient installation that's integrated into a control system for the sake of remote access and visualization. Or perhaps your project has a BMS that will handle control of the AC equipment but uses Polar Bear Design UMCs to control the underfloor heating. The project types highlighted here are more like the extremes of a spectrum, and the reality is that most projects sit somewhere in between them. Now, it's tempting to dive straight into the complexity of large-scale BMS and miss the simplest type of installation. So let's take a moment to look at that. A Polar Bear Design Zentium 2 or Inertium thermostat that's controlling just a room's AC unit. In this scenario, the thermostat is powered by a 24-volt power supply and communicates with the indoor unit via a Modbus interface. This simple arrangement allows Polar Bear Design thermostats the ability to control units from a wide range of manufacturers simply by selecting a suitable interface. We have support for many brands of interface and so support for many brands of AC unit. Since the thermostat can support up to 2 rooms, you can connect up to 2 interfaces so that each room benefits from independent AC control. An AC unit's reading of the room's temperature is taken by measuring the temperature of the air that's drawn into the unit before it passes through it. It's known as the return air temperature and can be a good measurement to use, but it's not always. Sometimes the location of the sensor or the way the air does or doesn't move through the system can mean the return air temp can be significantly out. To counter this, most AC manufacturers have a sensor in the remote control of the unit and offer the option to use that instead. Polar Bear Design thermostats, however, go one step further. Each Zentium 2 or Inertium has a built-in air temperature sensor, plus 5 ports to wire in additional sensors. These extra sensors can be used to measure air temperature or floor temperature in either of the 2 rooms. It's possible to assign multiple sensors to the same task, say air temperature measurement in room 1. And when you do that, those measurements are blended using a sophisticated averaging algorithm. This gives the thermostat a room temperature reading that is much more representative of the temperature experienced by the people in the room. This blending can include the return air temperature reading from the AC unit, so the occupants can still benefit from this, even without adding additional sensors, just by using the built-in sensor and the AC unit's return air temperature. Considering each room, or each pair of rooms in this way, is a great approach even when designing a larger system. It's then straightforward to expand the design to incorporate other climate features such as underfloor heating. Each zone can have multiple sources of heating and cooling, but they don't have to. And depending where you are in the world, you might find that your projects feature a lot of rooms with just underfloor heating and relatively few with AC. Or, in other regions, you might find that your projects are exclusively AC oriented. Polar Bear Design thermostats are fully configurable and suitable for use in a wide variety of room configurations. An important side note for systems with underfloor heating is regarding the need to measure the temperature of the floor itself. Obviously, limiting the floor temperature will prevent damage by overheating, but we can also enforce a minimum temperature to help keep the system responsive. To be able to do this, the thermostat needs to be able to measure the temperature of the floor, so adding in floor sensors is a must. Introducing heating naturally means there's more system to control, which is where the UMC comes in. The UMC is Polar Bear Design's box of relays. It has 8 relays per unit, and you need 1 relay for each thing, valve, relay, or whatever it is that you need to control. The UMC is used to operate underfloor manifold valves, radiator valves, pumps and boilers in wet central heating systems, and relays in electric heating scenarios. It's also used for towel heater and domestic hot water control, so don't forget to factor those services in too when planning your project. Since the UMC will be controlling the heating equipment, there needs to be a way for the demand signals generated by the thermostats that are in the rooms to reach them. So a cable is run in a daisy chain between each thermostat and each UMC. The bus cable also carries power to the thermostats, so the whole system can be powered by one power supply connected to the bus. Inside each room, the thermostat will automatically engage the heating or cooling as needed to keep the room at the desired set point temperature and ensure that both heating and cooling aren't active at the same time. When there is a need for cooling, the thermostat will use the AC interfaces to instruct the AC units. When the thermostat decides that there is a need for heating, the UMC is signalled over the bus cable and it controls the necessary equipment to heat the room. In rooms with multiple sources of heating or cooling, the installer can adjust the parameters of these stages so that they behave predictably and effectively. So, our thermostats have a rich feature set that can simplify complex heating and cooling and distill the control down to one super intuitive dial. They can be used in isolation or linked together. So just how big can a system get? Well, we can host up to 32 devices. That's any combination of thermostats and UMCs per bus. That's potentially up to 64 zones of climate control. If you have a bigger project, that's no problem. You just need to use multiple buses. The only requirement is that the UMCs are on the same bus as the thermostats that control them. Most installations that get to this sort of size will use some form of control system so that the user can access their climate controls from the same interface as their lighting, security, and AV. So how does integration work with a system like this? Without getting too technical, although do feel free to join me on tech training for a deeper dive, it's usually done by adding a gateway to each bus. The type of gateway and how it's configured can be different for different control systems and project needs. This diagram illustrates one of the most common approaches. Adding a control system unlocks another powerful polar bear design feature. The UMCs can be upgraded by the application of a license to host the same powerful thermostat logic as is found in the Zentium 2 and Ursium in-room thermostats. These so-called virtual thermostats can be a convenient and cost-effective way to provision rooms that have climate services but for whatever reason, be it a shortage of wall space or budget restrictions, don't have an in-room thermostat of their own. In this scenario, the sensors for measuring air and floor temperature are cabled to a UMC, and the UMC takes on the role of thermostat. The UMC2 ETH even has the accessory port required for AC control. All that's missing is the UI, which is provided by the control system. For many projects, this style of climate controls is a perfect fit. There are occasions, however, though, when direct AC controls aren't possible. Centralized AC and VAV type systems, for example, require a different approach, one that's often handled by a building management system. On very large projects, or those with complex plant arrangements, the same can be true for heating systems too. But being big, complicated, or having a BMS doesn't rule Polar Bear Design products out of the project. Far from it. Some of our largest installations are designed in exactly this way. In essence, the thermostat is used in the room as a set point adjuster, an attractive way for the occupant to inform the BMS of what temperature they want the room to be. Sometimes the thermostat also handles temperature measurement, sometimes not. It is possible to write the room temperature back to the thermostat. With this type of system, sometimes the BMS connects to the start of the Polar Bear Design bus directly. Polar Bear Design products natively work using Modbus RTU on RS485, a very well-known and well-supported protocol that all BMS engineers will be really familiar with. Sometimes the nature of a project is such that converting to a different protocol makes more sense. In this case, the most common solution is to use a Modbus to BACnet IP gateway, although gateways exist for other protocols such as KNX, so installers are free to choose whichever protocol best suits their installation. The gateway can also provide a neat point of demarcation between the remit of two companies collaborating on the same project. The Polar Bear Design installer looks after the thermostats and ensures the necessary data is available through the gateway in a format their counterparts can consume. If you need to control AC, if you have underfloor heating, radiators, towel heaters, and hot water, and whether you have a BMS or are looking for a standalone climate control system, there is a good chance that Polar Bear Design products can be part of the solution. Thanks for taking a moment to learn about our products. If you'd like to learn more, why not head to our website, www.polarbeardesign.co.uk, or reach out to us on social media. We'd love to hear from you.